Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared. So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now, what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now, I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now, by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end. Alright, so in this video, I'm going to be solving the equation 7 to the power of x is equal to 70. So before we start on our solution, let's notice that this is an exponential equation, and x is an exponent, which is the variable we're solving for. So let's just try to plug in a number. Let's start with 1. So we have 7 to the power of 1, and this is equal to 7. Now, let's go one higher. Let's go 7 to the power of 2. This is equal to 49. And now let's go one higher. Let's go 7 to the power of 3. this is equal to 349. So notice how we're trying to find what value of x that we should take the power of 7 to equal 70, but even the number 3 results in a number much higher than 70, meaning the value of x is going to be a decimal somewhere in between 2 and 3. So now to actually solve for x, my equation is 7 to the power of x is equal to 70. And what I'm first going to do, and what I recommend doing for any exponential equation such as this, is taking the log on both sides. And the reason you should do this is because now you can use the property log a to the power of b. I can move this b to the front, so I get b times log a. Log a to the power of b is equal to b times log a. And the reason this property is so useful is because before, x was an exponent, and it's really hard to solve for x in its previous state. But now I can move x to the front, and it's going to be an actual term. So now I get x times log 7 is equal to log 70. Now, log 70 is the same thing as log of 7 times 10. And another property of logarithms is that if I have something in form log a times b, this is equal to log a plus log b. So log of 7 times 10 is going to equal log of 7 plus log of 10. So now from here, what I'm going to do is divide both sides by log 7, because we obviously want to isolate x, so the only way to do that is to get rid of this log 7. So then these two cancel out, and I get x is equal to log 7 plus log 10 over log 7. And I can rewrite this as log 7 over log 7 plus log 10 over log 7. Now log 7 and log 7 cancel out, so I get x is equal to 1 plus log 10 over log 7. And if you guys already didn't know, log 10 is actually equal to 1. So now I get x is equal to 1 plus 1 over log 7. And this is my answer.